This is the application video for March 27th.
Golf club can be an example of parallel axis theorem. In golf, forgiveness refers to construction and design elements in golf clubs that lessen the effects of bad swings and poor contact with the ball. Usually, this kind of golf club has a heavier club head. The reason behind this is inertia. When you have a heavier club head, the center of mass is shifting further away from the grip, which makes the inertia greater. As a result of that, players are less likely to move during the swing and more likely to hit the target, and less likely to be angry.
Here's another example of the parallel axis theorem. As we can see pictured here, the ISS is an incredibly complicated shape due to the years of modulated additions to add new solar panels, scientific instruments, and larger living spaces. With every new piece that comes or is moved around, its moment of inertia changes, and thus new adjustments to the attitude thrusters and gyroscopic devices must be made so that they can accommodate the new shape. This is all possible due to the parallel axis theorem, which allows ground control to maintain a precise knowledge of the moments of inertia and is what allows for precise docking maneuvers going forward.
Traction wheels are designed for optimal grip on soft surfaces, such as the traction wheels used on the Mars rovers. We can use the parallel axis theorem to calculate the moment of inertia of the entire wheel. If all of the mass on the wheel was located on its rim, then the moment of inertia would be simple to calculate. However, since there is mass unevenly distributed along the radius of the wheel, we must use the parallel axis theorem to solve for the total moment of inertia. This can be done by calculating the moment of inertia about the centroid of the wheel and adding m times d squared, where d is the distance from the centroid of the axis the wheel will be rotating around.
Gyroscopes are mechanical devices with applications throughout the aerospace industry, and are most easily defined as a wheel mounted in 2 or 3 gimbals. The axle of the spinning wheel defines the spin axis, and this wheel responds to an applied force by a reaction force to the output axis. And an example of this is an attitude reference gyroscope, which is a gyroscopic flywheel with free-moving output gimbals, and is commonly used in aircraft and spacecraft for pitch, roll, and yaw outputs. As we can see in the figure, the combined rotations omega s and omega p induce an acceleration with force components a1 being normal to the wheel on the top, and a2 being normal to the wheel on the bottom side. The constant torque supplied by gravity is able to maintain the angle theta as the object moves with omega p, or the precession of the body. The same effect seen in the gyroscope explains how the long axis of a football is able to remain aligned in flight, wherein the gyroscopic response to the aerodynamic forces keeps the football aligned with its flight trajectory.